we have already mentioned that if we want to study any health-related problem, we can get information either from different resources or sources which we have already discussed. And one of the methods of studying a health-related problem is by epidemiological studies. By the epidemiological studies, we can study the occurrence of the disease, the distribution of the disease, and the determinants of the disease. So there are different types of epidemiological studies. We are going to discuss some of these important studies. So the main objectives of this lecture is to know the different types of epidemiological studies and when we are going to do a different type or we are going to choose the appropriate epidemiological studies. So the epidemiological studies, it is divided mainly into two broad aspects, which is either the observational studies or the experimental studies. By the experimental or interventional studies, it means that the researcher will try to change or intervene or try to make any intervention among the studied group in order to see the effect of this intervention. So the researcher will, or this study involve an active trial to change the disease determinant or causes by the investigator who control the exposure, and he follow the effect of this intervention to see the effect on the study group. So the investigator will allocate, or the researcher allocates the exposure and follows the subjects. So the participants are identified, or the studied group, they are identified on the basis of their exposure status or the intervention and followed to determine whether they developed the outcome or not. So by the interventional or experimental study, it means that we are going to add an intervention or expose some people to certain effect, and they want to see if we are going to follow up this group to see the effect of this exposure, and this is called interventional, to see the effect of exposure which we have applied to certain group of people to see the effect. For example, the study of the efficacy of drugs. So we are going to take groups and we are going to expose them to this group, to this drug or vaccine, and then we follow up them for a period of time to see whether they develop the disease or the outcome after the intervention. While the observational studies, the researcher observes the group and systematically collect information, but there is no trial to change the people. We observe the people as they are without any intervention, and it is divided into descriptive study and analytical studies. The descriptive studies, there are two types of descriptive studies, which is the cross-sectional study and the longitudinal study. While the analytical study, there are two types, case control and cohort study. In the analytical study, we are going to determine the cause of the disease, or we are going to study the association between the cause and the outcome, between the exposure to the certain risk factor and the outcome. So the analytical study, they are comparative studies. We are going to involve two groups, and then we are going to compare the association between the risk factor or the exposure and the outcome, which is the disease. While the descriptive studies, we are only going to observe the group and describe the disease as it is present in the studied group. So the study design, as we mentioned, there are two groups. Does the investigator, we are going to ask the question, does the investigator decide for exposure or intervention? Either yes or no. If the investigator try to intervene or expose the people to certain exposure or intervention, this is called the experimental, as we mentioned. And there are either we are going to make randomization, and we are going to discuss this in the future, or not. And we are going to leave this to another lecture. While if the investigator does not decide to expose the people to certain intervention, so we are going to follow the observational or non-interventional study, as we mentioned. And you ask yourself, are you going to take a comparison group or not? If not, we are going to take this descriptive study, which is the cross-sectional and the longitudinal. And if we want a comparative group, we are going to use the analytical study, which involve the case control and the cohort study. So the observational studies, descriptive studies, it is a simple description of the health status of the community based on routinely available data, either health-related data or the data that obtained in a special survey or examination for certain people. So pure descriptive studies make no attempt to analyze the links between exposure and effect. We are not going to study the association or the link between exposure to certain risk factor and the occurrence of the disease, but we are going to describe the disease as it is in the studied group. So they are two types of studies, which is a cross-sectional and the longitudinal study. And some studies, or these studies, they are based. Sometimes we use the mortality statistics or morbidity statistics and examine the pattern of the disease in certain persons regarding time, place, and characteristic of the individual during specific period of time. The cross-sectional studies, it assess the presence of disease and risk factor at a point of time. We are going to take a group of people at a point of time, and then we are going to see the presence of the disease or the presence any health related factor or events which it is under the study. So these are based on a single observation, usually carried out in a short time. So each individual involved in the study, he will be examined just once, or he is going to be interviewed just once. No repeated examination or no repeated interviewing. So each individual have a single observation. Each individual have one measure or one question, and there is no repeated examination or assessment. So this study is characterized by, or it is used in the following situations. It is used to study conditions that are relatively frequent with long duration of expression, which is non-fatal, especially in a chronic condition. It is important to study the chronic diseases or individuals who have chronic diseases regarding the distribution of the disease and with respect of the age, time, and the place. And it is we are going to measure the prevalence of the disease or the any health related event. So each individual will be examined one. For example, if we want to study the prevalence of anemia in a population or in a school children, so we are going to take a sample of the this school or different schools, and we are going to assess for anemia just once. Each individual or each pupil will examined one, and we are going to assess for anemia and see how many individuals have have anemia at that time, at that point of time. So it will measure the prevalence of anemia among school children in certain period of time. Also, they are not useful for diseases of short duration or rare diseases or highly fatal disease. So this type of study, we cannot use it for the assessment or studying for diseases which are of short duration or rare diseases because or fatal diseases, because it is one measure at a point of time. At that time maybe there are no cases of that diseases, so we cannot use it for fatal or highly recovered disease with high recovery rate, so or short duration, so we cannot use this type of study. A single observation may miss cases. It tend to identify the prevalent cases of long duration, since people who sometimes people who die quickly or recover quickly or who are no longer employed in a particular occupation are less likely to be identified. As we mentioned, for example, if we want to study the effect of certain occupation on a group of certain workers, so if the individual were absent at that day when we performed the study, and maybe because he is absent because of the problem of or the disease which it is under the study, so we cannot use so we are going to miss some of the cases, or we are going to miss reporting or underreporting of cases. They suggest hypotheses. By the end of this study, we are going to assume a hypothesis. For example, we are going to assume hypotheses such as, for example, anemia is more likely to occur at school among school children at, for example, at younger age group, for example. So this is a hypothesis. But this is not the end of the situation, because we have to perform another study to see if this association is or this assumption is true or not. So it is for suggestion priorly for hypothesis or suggestion of a hypothesis, and we are going to perform another study to see whether this hypothesis or this assumption is true or not. So it is regarded as a starting point for another studies, which is the analytical study. Always we are using the cross-sectional as a starting point in suggesting the hypothesis by taking or by choosing the cases or the controls in the analytical study. So it is regarded as the starting point for the analytical study. It has been mentioned that the results are difficult to interpret because of seasonal variation and cohort effect. Sometimes, it is difficult to study the seasonal variation among the seasonal diseases. For example, allergy. In allergy, there is a seasonal variation. It occurs in certain season. So we cannot use this or choose this cross-sectional study to study the prevalence of allergy in the case in the months where there is no allergy. So it is not important for diseases which have a seasonal variation. They are relatively quicker and cheaper. This is regarded as one of the advantages. So it is relatively quick and cheaper than other studies. So the advantages and disadvantages of cross-sectional studies. The advantages, it give general description or scope of the problem, useful in health service evaluation and planning, and it is regarded as baseline for prospective study, and identifies cases and control for retrospective studies such as in the case control, and it is low cost and it is quick. While the disadvantage, no calculation of risks because we cannot study the association or study the cause of the disease or the determinant of the disease. Not good for rare disease, as we mentioned, and selective survival can lead to bias. For example, as we mentioned, if we want to study the prevalence of certain occupational group, a certain occupational disease among a certain worker, so if the worker they are absent, as we mentioned, from their work because they developed the disease and they died or they are absent, so this will lead to a bias of the result or underreporting. Selective recall can lead to bias. Sometimes some people they cannot recall or they have memory problem, so also this will lead to bias. Another descriptive study is the longitudinal or the follow-up study. We are going, the researcher or the investigator, he is going to choose a group of people and he is going to follow up them for a period of time, and he is going to study these people for a period of time. So these are based on repeated observation. We are going to choose individuals and we are going to measure, we are going to ask them or examine them periodically to see whether they develop certain outcome or not. For example, if we want to study the incidence of pediculosis, it is one of the insects or parasites which affect school children, and it is one of the problems among especially the primary schools. So if we want to study the prevalence of pediculosis among school children, we are going to take a group of children among in different schools, and we examine them just one time and to see how many individuals have pediculosis at that time. That is the prevalence in cross-sectional. But if we want to study the same problem in longitudinal study, we are going to take certain group of school children, and we are going, for example, start the study at the beginning of the first semester in September, for example, and we follow them until the end of December for at the end of the first semester, and we are going to examine them periodically. For example, every 2 weeks, every month, and see how many individuals develop the pediculosis during this period of time. So we are going to measure the incidence of pediculosis among these cases. At the beginning, on the 1st of September, we are going to examine all the students. So, and we see how many individuals have pediculosis at the beginning of the semester. This is the prevalence. That is, so the longitudinal study started with or by cross-sectional. On the first day of September, for example, we are going to examine the sample or the group of the school children and see how many student or pupil have the disease or pediculosis at that day on the 1st of September. So this is the prevalence of pediculosis. And then we are going to follow the same group for a period of time until the end of the first semester, and we are going to examine them periodically every 2 weeks or every month, and then we are going to record how many new cases of pediculosis developed during this semester. So we are going to measure the incidence, the new cases of the pediculosis during this period, which is the first semester. So these are based on repeated observation of the study population over a defined period of time. So they start with a baseline data provided by initial cross-sectional study, as I mentioned, and they measure incidence of the disease or related outcome who is going to develop the disease during the period of follow-up. And also they suggest hypothesis By the end of the study, we can say that tuberculosis is one of the insects or parasitic infection which is common among school children. They are relatively more expensive and difficult to organize. It need a periodic examination. It need time. It is time consuming, and it is costly. We need resources for the follow up and for different examinations. And we need, for example, a team of the research of for the research, so it is time consuming and money consuming. They are not useful for diseases of rare occurrence also, because we need a long period of observation, and this will be very expensive to carry out this study, especially if the disease have long duration to appear or to occur. The results are easier to interpret, and they can be useful to determine seasonal variation of disease and other health related outcome. If we want to study the seasonal variation of allergy, so we are going to start from January until the end of the year, until the end of December, and we are going to see and examine periodically and see how many individuals develop the disease during different months, and we are going to study the seasonal variation. Analytical study. So in the longitudinal study, we are going to measure the incidence of the disease, and one of the problem is the missing of some cases. Sometimes by repeated examination, we may miss some of the cases in the follow-up period. Analytical study, the researcher attempts to explore how and why a disease process is initiated or maintained in a given population or place. So we are going to study the determinant or the causation to confirm that the disease is caused by certain risk factor. So we are going to take two groups. Always we are going to take two groups, which are the study group and the control groups, and we are going to study the disease and the relationship between the disease or the outcome and the exposure to certain risk factor. So the analytical study, it is to study the association between certain exposure to certain risk factor and the occurrence of certain health problem. So we have two groups, the study group and a comparative or the control group, which are we going to compare between the occurrence of the disease or the presence of the disease in relation to certain exposure to risk factor. So we are going to test the hypothesis so that they are accepted or not. We have assumed hypothesis by the descriptive study, but by the analytical study, we are going to test the hypothesis. Is it true or false? Whether we are accept the result that there is association between the cause and the exposure and the disease or not, and this is by application of certain or two different methods in the study this association. So the hypotheses are either accepted when we have adequate evidence to support them. We are going to explain how are we going to see if there is association or not, and whether the hypothesis will be accepted or not. When the evidence is inadequate, so the hypotheses are not accepted and further studies may be required. So to use example, it might be suggested hypothesize that parental smoking among parents increases the risk of acute respiratory infection among children aged under 5. There is an assumption by, for example, if we make a cross-sectional or longitudinal study, and we saw that the respiratory infection is more common among children for whose parents are smoker. This is an assumption that this respiratory tract infection is more common among children where whose parents are smoker. So it is important to accept or refuse this assumption or this hypothesis by performing analytical study. So we are going to take either cross-sectional case control study or cohort study. So we are going to take two groups and we are going to discuss the difference between these two studies. So, we have already discussed the term retrospective and prospective. So, retrospective, we are going to study or go backward and see if there is exposure or not. While the prospective study, we are going to take a group of people who are exposed and we are going to follow up them and we see how many of them will develop the disease while they are exposed. So in the case control study, it is a retrospective study. We are going to start with the disease. We are going to start with individual who have the disease, and then we are going to ask about whether they have been they have exposed whether they have exposed to certain risk factor or not. So this is the retrospective study. While the cohort study, it is the prospective study. We are going to start with the exposure with individuals who are exposed but they don't have the disease, and we are going to follow up them to see if they will develop the disease or not. And we are going to discuss each one separately. So the case control study. In the case control study, both exposure and outcome or the disease have occurred before the start of the study. So we are going to start with the disease, and then we ask them about the previous exposure to the disease. So we go backward, so it is retrospective study, and we ask them if they have exposure or not. So we are going to take two groups: cases, individual who have the disease, and the other group is the control group, which who have no disease, and we are going to compare regarding the exposure. Controls are used to support or disprove any inference or association. So, for example, if we want to study in the same example which we have already mentioned, the association between parental smoking and respiratory tract infection among children. So we are in the case control study, we are going two groups. The first group, we are going to take cases. The cases who are the cases in this example? The cases, they are children under 5 years of age who have respiratory tract infection with the disease. These are the cases. While the control group, we are going to take a group of children who are under 5 but they have no respiratory tract infection. Then we are going to ask the parents of the two groups we are going to ask the parents of the cases if they have history of smoking or they are smoker, and we ask the control also if they have history or they are smokers. Then we are going to see how many children have respiratory tract infection, their parents are smoker, and how many children who have the disease but their parents are not a smoker. So the first group are the cases and the other group are the control. So the control should be matched with the cases for certain factors which are called the confounding factors, which may affect the occurrence or the occurrence of the disease or having the disease. So the survey may involve so this are either we as case control study, we are either the researcher will just ask questions or perform certain examination or take from other records in order to see the history or the risk of exposure. So the basic question, what differs in the histories of these two groups that could explain why one group is diseased and the other is not? So the basic design, two groups of persons are studied. The first consists of subjects who have the disease under the study at the time of the beginning of the study. These are the cases. And the second group, subjects who have no disease, who are the control. And both cases and controls are peripherally matched for age, sex, and other factors which may affect the results, which is called the confounding factors, which affect the result of the or cause bias in the result of the disease. And we are going to discuss about the bias and confounding factors later on. So sometimes they are matched for other variables, but overmatching sometimes it is not preferable. This should be avoided. So the impacts of confounding factors, it is important to study the effect of confounding factors. The confounding factors, it is defined as the occur when confound factor when the effect of two exposures or risk factor have not been separated, and it may affect the analysis and conclude or affect the conclusion that the or affect the association of the or affect our result. So for example, the family, if we want to study the association between iron deficiency anemia and the large family size or family size. So, the outcome is the iron deficiency anemia, and the exposure is the family size. We want to study the association between family size and the iron deficiency anemia. So we are going to take children with iron deficiency anemia, and then we ask how many children, so the first group are children who have iron deficiency anemia, and the controls are children who have no iron deficiency anemia. And we ask for a previous or we ask about the family size, how many individuals in the family, and this is regarded as the exposure. We want to confirm this association or not, but we should take in consideration that there are other factors, the confounding factors, which may affect the disease occurrence or the presence of the disease, such as different parasitic infection, such as ankylostoma, duodenale, or certain other parasitic infection which cause anemia, iron deficiency anemia, or the pattern of diet, inadequate diet, for example, or mother awareness or education. So all these factors regarded, or socioeconomic condition, which is regarded always as a confounding factors, which affect the result of the disease. So the steps to conduct the case control study, we are going to select cases, individual with the disease, by establishment of the diagnosis criteria, a standard case definition. So each, for example, for anemia, there are standard definition of the cases. Who are the cases which you are going to take according to the cutoff point, for example, in hemoglobin, and you are going to take the standard definition of the case in choosing the cases. Sources of the cases, or from where you are going to take the case, either from hospitals or any health institution or facility, and general population, or from the general population, from the neighbor, from the the hospital cases, or any health center or general population, and the selection of control by doing the matching, match the cases and the control and the sources, either from hospital, other individual, other patients in the hospital, but they don't have the disease under the study, or relatives and neighbors. But usually relatives, they have the same confounding factor, or same, especially for they are not preferable for studying the genetic factors. If we are going to study the genetic disease, or the nutritional factor, also they have the same habit and same behavior, so it may result in confounding factor. Also, it is important to assessment of the exposure, as how many or number, what is the number of cases who have history of exposure to the risk factor, and then we are going to analyze and interpret the result. So the first thing, we are going to put a 2 by 2 table. Put a table, convert your data into a table which is called the 2 by 2 table, or four-folded table, and then you are going to put the flow chart and calculation and interpretation of the result by the calculation of the odds ratio. Selection of the control, as we mentioned, by performing the matching, and we look for the confounding factors, as we have mentioned before. The sources of the control, either from, as we mentioned, hospitals or any healthcare facilities. Relatives, they are not sometimes they are cooperative, however they are unsuitable control when genetic conditions are under the study, or dietary or nutritional problem studied, they have the same diet or same behavior. Neighbors, they are good source of general population, but it is expensive and time consuming, and sometimes it's difficult. Sometimes you see that the people, they are not cooperative. So the size of control, it depends on the size of the cases. How many cases you got, you can match and give either the same number, or you double the number or triple the number according to number of the cases. So some literature, they mention that if you have more than 50 cases, so one control may be enough for each case. You match one case for one control. While if the number is less than 50, so it is preferable to have more number of controls, so either double or triple or quadruple. The assessment of the exposure by interviewing, by questionnaire, or by, as we mentioned, or studying the past record, or from hospital, or from the school, or from occupational records. The analysis and interpretation of the result, we are going to put the table, 2 by 2 table, and usually we start by the cases and the controls, and we are going downward in the calculation, the cases and the control, and we are going downward, and then we are going to ask about who are exposed and who are not exposed, about the two groups. So the A is they are the cases who are exposed, who have the exposure, while B, they are the control, while the B, they are the control, but also they have exposure. And the C, they are the cases or individual who have the disease, but they have no history of smoking, for example. And the control, D, they are the control, they don't have exposure. So it is important to know these for letter and what each letter denotes to what term. So then we are going to calculate certain calculation which is called the odds ratio. So the odds ratio, it is equal to A multiplied by D divided by B multiplied by C. So it is AD divided by CB. And by now we have already known what A denote and D denote and what B denotes and what the C denotes. So the rate of exposure, it is called before the odds ratio, we are going to calculate the percentage distribution of the exposure among the cases and among the control. How many cases they are or they have history of exposure to the risk factor. So the A, they are cases who are exposed to the risk factor. So A, distribution of exposure among cases equal to the A divided by the A and C. So A divided by A and C. So this is the percentage distribution of the risk factor among the cases, while B is the B divided by B and D multiplied by 100. It is the percentage of distribution of the risk factor among individuals who have no disease. Then we are going to compare the result of this percentage. If by just seeing the percentage, we can mention that the exposure is higher among cases rather than among control, and we are going to discuss by example. Then we are going to estimate the risk, if it is there is association or not between the exposure and the disease. So we are going to measure the strength of association between the risk factor and the disease, which is called the odds ratio. The odds ratio is equivalent or it is synonymous to the relative risk. So the odds ratio equal to A, number of cases with risk factor, D, number of control without exposure, divided by B, which is number of control with the exposure, and C, they are cases without exposure, as you see in the bottom of the table. So what is the risk factor? What is the odds that a case is being exposed? It is equal to the A. It is equal to the A divided by the A plus C, and it is divided by the C, which is the number of the cases with no exposure, and divided by the A زائد C, and it is equal to AC. This is just the calculation in mathematical calculation, how they got the result of the odds ratio. So at the end, odds ratio, by just seeing this calculation, you can see that the odds ratio is equal to the AD divided by the BC, and we have all explained these terms. So the result of the odds ratio. So the odds ratio is the measure of the strength of association, and it's similar to the result is similar to the that of the relative risk. So if the result of the odds ratio is 1, so there is no association between the exposure and the development of the disease. But if the odds ratio is less than 1, it will be, that means that the exposure is protective, as we mentioned in the previous lectures, and so the risk factor or the exposure, sorry, the exposure is protective rather than it is a risk. While the if the odds ratio is more than 1, so the exposure is associated with the development of the disease. Also, there is a relation between the risk factor and the disease. To illustrate the study, we are going to take an example. If we take children, 200 children who are suffering from acute respiratory infection, such as pneumonia, and an equal number of or more, such as 380 of children who have no respiratory tract infection or free from infection, and we are going to match regarding age and certain age or sex or other confounding factor. These are the controls. So we have two groups: the cases with the pneumonia, for example, 240, and 330 controls who have no disease. And then we are going to ask the mothers of the cases, are they smoker or not? So now so the risk factor or the exposure is the smoking of parents, while the control they are normal children, but also we are their mother, they have no smoking. So now we are going to, or sorry, they have no disease. Sorry, they have no disease. The control mothers, children for mothers of normal children who have no pneumonia. So we are going then to ask the two groups or the mother of the two groups about the history of smoking. So we are going to ask the smoking habit is the exposure or the risk factor, and we are going to try to know whether parents do smoke or not, and if they do, what is the number of cigarettes per day in this group. So suppose we found that the parents of 170 cases, they are smoker. So 170 children who have pneumonia, their parents, they are smoker, and 200 children who from the control, they are also a smoker, the mothers. So we are going to perform the 2 by 2 table, and we start with, as we mentioned, the cases of pneumonia and children without pneumonia, cases and control. And then we are going on so this is we are going by columns, the cases and controls. We are put them in a column, and we are going downward, while the exposure we are going on the right side, whether the exposure to the risk factor, whether smoking, whether positive or negative. And then we are going to ask the how many cases, how many from the 240 children, how many of them their mother were a smoker. So they are 170 children, their mother or their parent, they are smoker, while regarding the controls, they are children with no respiratory disease, but there are 200 children from the control, their parents, they are smoker, which is B. And this is the C, which they are cases, but there is negative history of smoking, and 180 controls, they have negative history, their parents have no smoker. So these are this is the most important point, is the application or having the data in or constructing in the data in a 2 by 2 table. So by now we know the A, they are cases with the risk factor. C, they are individual have the disease but no risk factor. While the B, they are the control without the disease but they have history of their parents a smoker. While D, they have no disease and they are their parent not a smoker. So the second step, we are going to calculate the percentage distribution of smoking among the parent of the cases, and the percentage of smoking among the children where their parent they are not smoking. So 170, which is the A, divided by the A and C multiplied by 100, so 70, nearly 71% of the cases their parents were or they are smoker. So this means the 71, nearly 71, it means that nearly 71% of the children with respiratory tract infection, their parents are smoker. While for the control, we have only 52 or 53% of the control, there is history of smoker among their parents. So by just looking to the percentage distribution, we can see, or we can say that cases were more likely to be children of smoker parents. The third step is to measure the strength of association by the calculation the odds ratio, as we mentioned. So the odds ratio equal to the A multiplied by the divided by the C and the B, and by now you know what each letter denote to what. So the odds ratio is equal to 2.2, and this can we by calculating so the odds ratio is more than 1. So this means that the risk of acute respiratory infection among children of smoking parents is nearly twice or 2 times than the risk among children of parents who are not a smoker. So the benefits of the case control study, it is suitable to test the hypothesis that the disease of the interest is caused by an exposure for disease with long latency and period, and it is also important for rare diseases, and it is easy, rapid, and cheap compared with the prospective study or cohort, which need a period of follow-up and requires few subjects. Sometimes you can take a small number of sample for the comparison, and it can examine multiple exposure factors for a single disease and estimate of the risk factor or the odds ratio, sorry, and there are minimal ethical problems. There is no need to, for example, sometimes to have certain informed consent, and which is sometimes it is difficult to take from some people, and there is no that any intervention which may hurt the individual, or you are just going to take the case and you are going to ask about the previous exposure. It is not costly. There is no iteration problem. It is not costly and does not need too much resources. While the limitation of the case control study, we cannot calculate the incidence and the prevalence rate from this study, because we are taking sample. We are not going a group of people. We are not going to take a group of people and follow up them and to see how many individuals develop the disease. But we start with the disease, so we cannot estimate the incidence or the prevalence of the problem. Not suitable for studying rare exposure. Sometimes if there are rare exposures, for example, so it is not important, or it is not suitable. And there is also the problem of bias, and we are going to discuss how we are going to eliminate this bias. Sources of control we have already mentioned, so no need for repetition of this one. So it is just a repetition for the sources of controls or cases. And thank you.